Right. So, ladies and gentlemen, welcome again to our next session, our other session. So, we're going to continue with our booklet that we use to facilitate the electro-pneumatic labs. So, I believe that last week we covered exercise 1, 2, and 3. So today we're going to do things a little bit different. Uh, I'm going to design these labs like on screen first, so that we cover the desired content and the required content, and then after that we build uh, some of the complex exercises that we would have encountered. So for today's session, I will try to work with you guys. So be ready to send me messages as we go along. And I'm not sure if we do have the option for raising hands here. Yeah, we are having. So yeah, so today's session we are definitely. I'm gonna require you guys to participate, and so that we have a more engaging session. So let's start. Let's start right away. Let's start right away. So now you are required to set up indirect actuation. Yeah, and if if my memory serves me right, you will always be required to set up every exercise, not necessarily every exercise, but I'm requiring you to when when I test you to know that by default your circuit is an indirect actuation. I don't need to mention it in the lab, in the test, or in the question that you are doing an indirect actuation. And therefore, if stated otherwise, you will be informed that you are doing the direct actuation. So I'm not giving out what the test will look like, but all I'm saying is if it's not stated that it's direct actuation, you do the indirect actuation. Or by default, all tests come as indirect actuation. Okay? So we are required to be able to select the correct solenoid valves based on specified requirements. And also here they want you to be able also to convert solenoid valves. The app we are using, uh, the software we are using doesn't allow us to convert. So I'll show you how I'll do the question and how they presented the question. Then maybe we can engage each other on those differences. Okay. So we have plastic pallets need to be filled from a storage silo. Me, I would assume this is a storage tank, but it's fine because I'm not familiar with the term silo. And then the silo is opened and closed with a flap. Yeah? Okay, so I assume this is a flap. And then the process will be started from 2 locations. Okay, so basically what they're saying is the process can be started from 2 different locations. So meaning you might expect multiple push buttons, okay? And then the flap is opened by pressing either one of the two push buttons, okay? Either, you see that obviously we know we are on third year, so we should be knowing what either means. It's either or, one of the two push buttons, okay? So if you are informed how many push buttons can start the process, obviously you don't need to surprise yourself. First thing first, put two push buttons on your circuit. Are we clear? Put two push buttons on the circuit, and the bulk material is emptied out of the container. So when we start this, and so basically after that the material is emptied, it means that our cylinder opens up this whatever tank when we press the push button, okay? When the push button is released, the flap is closed. So this is to tell you the type of cylinders being used today. So it means that on the normal state, the cylinder must be on extended end position, ne? Extended. So you need also to appreciate the terminologies, extended and retracted. Ne? Extended is equals to advanced. So those are the two terms I use. Retracted. So when the cylinder is extended, that is extended end position with an E. Extended end position and retracted end position. So in this case, a single cylinder will be a single acting cylinder will be used. Who can tell me how different a single acting cylinder differ from the double acting cylinder? Who can just answer us quickly with just a simple explanation? Any volunteer? Even if you write on the text, I will answer. Okay, it only allows one input as a spring return. Okay, so you only power it from one input, and it has a spring return. So meaning that it doesn't require a certain mechanism to return. So it comes back by default using a spring. So it has a spring return. Okay, so you are the control of the cylinder will be executed indirectly by means of a push button. And in the event of electrical power failure, the cylinder piston rod should be advanced to the forward end position. So look there now. So by default, the cylinder must always remain in the advanced end position. Okay? Then now they want you to answer these questions. Answer question concerning the conversation of solenoid. So this week, as I mentioned, we can't be able to convert, and select the suitable solenoid valve. Okay. Since while you guys are not doing the other, how can I put it? You don't do basic pneumatics. You do the electro-pneumatics. I will put I'll put for you when I design the circuit, I'll put two types of valves there. So all these things we are dealing with, we are controlling valves, but they differ on how they are being actuated. Yeah? So if it was a hydraulic valve, it was going to be a hydraulic valve. If it was a pneumatic valve, it was going to be a pneumatic valve. But we are using a solenoid, which means electrical valve. Yeah? So when I ask you what is a solenoid valve, you need to be able to differentiate from any other valves. Since when we have done PLCs, and who can tell us what is an OR function? How is the OR function being actuated? Who can tell us with just a simple explanation? And when you don't have an OR, what do you have? So can somebody answer that question? There is no wrong or right answer. So can somebody remind us what is an OR? Even if you can unmute yourself just to answer us. Any contender? Okay. I guess I will explain it when we get to the other side. They say equipment list here. Okay, from the input side, when either of the both inputs are pressed, the outcome will be active. So basically, if we have that or gate or gate operated device, so it will be actuated with any of the inputs that are being pressed. In normal instances, there are two, but we know, okay, you don't know, I will inform you. You can go up to four, and depend who manufactured the device, maybe others can go up to eight. So if any of those inputs are actuated, you're gonna get a signal. Ne? So we still carry the term signal, so to avoid any confusion. Okay, I see here they mentioned double check your controller configuration. I would love one day to kind of design a circuit incorrectly and see if you guys can help me configure it so that it can run. Okay. Converting of solenoid valves, I'm not going to cover this section because our software is unable to do that. But in a real world, you could be able to. So, okay, in this case, they went with a converted 5-2-way valve, and I want to see why did they do that. They say they're selecting a 5-2-way valve because it can be used in a broad range of application. In actual practice, this means that only one valve type is required for a variety of requirements or applications. This can result in a considerable cost reduction in areas of valve procurement and warehousing due to larger quantities. As compared with the maintenance or for a single valve type, servicing and variety of valves is considerably more expensive. 3-2-way valves can only be used to actuate single-acting cylinders, but 5-2-way valve can be used with single as well as double acting cylinders. Therefore, it makes sense to buy a 5-2-way valve in the right choice for the reason the fact that the 3-2-way valve is usually about 5% less expensive than a 5-2-way valve is not decisive due to the above mentioned advantages of the 5-2-way valve. So they converted a 5-way valve on their answer. So as they mentioned, that is very vital according to what they are doing for you to understand a 5-way valve, to understand the actuation of a 5-way valve. So in this section here, we have our OR gate. Okay, unfortunately, we didn't do what you call function block diagram. So this is an OR gate of a function block diagram. Okay, and this is their answer. Let's not dwell much on the answer. Let's rather build it according to our own perspective. Okay, we needed a single acting cylinder, and we needed, okay, something that we haven't covered yet with you guys, a 3-way valve and a 3-way valve, normally open and normally closed. I'm going to do this for you so that for the first time, who can tell me why do I use a compressor? What we use a compressor? This is how a compressor looks like in real life. Why do we use it? Who still remember? And also, why do we use? All right, guys, there's something that I'm interested in. So you find that when we are testing you, you are now unable to. Before you can answer me, I need to clarify something. Students would find themselves with this screen. You see, I'm not able to access. Say maybe I want to put. I delete my compressor. I want to put another compressor, or I want to carry on, and my screen is like this. So you might feel stuck and not know how to react or what to do. So this is how you respond to this. You will restore. You see here, you don't go there. When you go there, it will reduce the whole screen. You see, you don't go there. You come to this smaller one here, and you would be able to see. So if it happens that you having this, you can't see it at all. You see, and you're like, hey, where's my work? Say my work disappeared. You start by minimizing this one, and you start enlarging them one by one until the right one comes up. So this is how you would find ways of bringing back your screen. Is very vital because I know when I test you students, they just faint. I know. Okay, so this is a compressor. What does a compressor do, guys? You are mechanical. You did compressor labs, if not mistaken, William. What does a compressor do? Give us in simple terms. What do this air compressor do? Any volunteers? Supplies energy to the fluid so it can perform work. What type of energy, say? I won't put you on the spot. So who can answer? What type of energy supplies pressurized air? Is the working fluid, okay. Muleya, we are not dealing with hydraulics. You are 100% correct. But if we were dealing with hydraulics, you were going to be correct. That fluid would be called hydraulic fluid. So we are not dealing with that fluid. We are dealing with compressed air. These are pneumatics. That's why we are saying electro-pneumatics. They breathe. Yeah? You send air into your devices and you are able to exhale that air so that your components don't remain with air inside them. So this system can breathe. So you put air in and you need to take that air out into your atmosphere. With hydraulics, it's a closed system. You can't release that air. So these pneumatics, they work most of the time in systems such as your, no problem, thank you. Yes, you understand. Okay. Yeah, sure. Pardon me, like that. Cheers. All right, ladies and gentlemen, sorry about that. This device, who still remember why do we have this device? It's called service unit. Who still remember why do we have it? Why do I put this device? Service unit. Okay, looks like no one. I'll just simulate. Oh, it's wrong. Anyway. All right, yes. The air service unit is to filter the air. As you know that when you compress air, that air might gain temperature and starts to create water particles. The water particles will be left in the aluminum grade equipment that we are using, or you'll be using in your facility in future in your company. And you know, water at some point will create what? Will create rust, and will also create blockages into the pipes. Then you lose your what? Your pressure. So the force of the cylinders will be dramatically be affected, and because they are pneumatically operated, you will have issues with their force, and the lifespan of that equipment also will be affected. Okay, so now we have these three two-way valves. As you can see, they are both actuated, and this one is normally open. Hey guys, yeah. Remember, normally open in PLC. Who can? Okay, I'm gonna put a switch now. Let me just put a switch. I want us to make a nice comparison together so that tomorrow we don't confuse each other. I know I'm using a similar term, but I'm using it in a different way. So let's now try to together find this. It's a okay. I'm just gonna put the relay there. Connect like that and connect there. Okay, like putting my stuff straight. Orderness is very important in this. So this is a switch, né? It's a push button, né? It's a make, aka normally open. You still remember it? All of you guys, you attended my lab. So it's a normally open. I am gonna simulate. Okay, why am I getting this error? I'm just gonna delete this and put it again there and connect and connect it. Right. My switch is normally open. This one is normally open. It's a valve. I'm closing my switch. It connects. And my valve is normally open. Who can, in short, tell us what is happening here? Like, this is a taboo, guys. I believe so. Why the other one, it's normally open, yet the substance or the air is passing. This one is normally open. We are expecting the electricity to pass also. Why it's not passing? Why it's not passing? Who can give us just an example why it's not passing? Why our electrical connection is not connected yet? We're calling this a normally open. A quick explanation, a simple one, straightforward. Unmute yourself and just say it. Oh, so somebody say we didn't assign a relay. Let's assign it. I'm gonna assign it for you, madam. Or say. Let me assign it very quickly. Tap. I'm assigning it to the solenoid like that. That I'm gonna label it 1B1. 1B1. Yes. And I'm gonna come there. 1B1. No, let me make it worse. Let me not label this one B1. I'll label the very same one that we're dealing with. 1B1. Now it's assigned. Now it's assigned. But that one, air still passes. That one, no. Nothing is happening. All right. I'm connecting. It goes back. I'm releasing. It goes forward. Okay. What's happening here is valves. Ne? They are more like your normal ordinary tap. Ne? Your tap is called tap valve, if not mistaken. That closing and opening mechanism of a tap, when you spin it, it closes. Then when you spin it, you like, guys, let's show you a normal valve. Let me show you on internet. Let me go to internet. Hey, you. Let's go to internet. Yeah. See? Hey, do you see that? Ordinary tap. At my home, we used to use this as our tap. So this operates exactly like a tap. Your valve operates exactly like a tap. So when it's open, what are you expecting? In industry, it would look like something like this. In a serious industry, you guys as mechanical engineers, you'll be dealing with these things like on a daily basis. Whenever you say I'm at work, these are the stuff you might find yourself working with them. So this, because there's a tangible substance inside. Yeah? Yeah, it looks like this. You see, this is a ball valve. When it's open, the substance can penetrate. You understand? The substance can do what? Can penetrate when it's open. And when it's closed, the substance can't. Yeah? And where's the solenoid valve? This is a mechanically operated valve. Yeah? Here's a solenoid valve. It looks funny, man. Why? So they call it electrical valve. Yeah. See? You see here they're calling it what? They're calling it electrical valve. Look at here. Electrical solenoid valve. It looks like this. When it's open, there is a flow. And then, but this one, it's an electrical contact. Ne? This one, it's electrical contact. It only operates when the, look, on electrical, on electricity, there's a flow of electricity and it gets limited by a switch. Ne? And then that switch, only when it's connected, the electricity can pass through. But with the valve, now the valve is closed here. The valve is what? It's closed. There's no more air passing through. So this one is normally open because the air can pass. I'm going to swap the two. I'm going to put this one there. I don't want to program this. I don't understand. So 1B1. Now we are assigning it. Observe. Okay, this one, because of it's normally open, the air will pass in. This one is normally closed. You see? Normally closed. The air doesn't go through. And when I press here, the air goes through. We've opened the tap. Water's coming out. The tap is called a tap valve. A switch. Let me put a normally closed switch, because people might say, oh, but what, but let's also test with a normally closed switch. Normally closed switch. Yeah? What happens to our valve? Our valve gets to be activated. I press there. You see, when I press the switch, the switch is, because of it's normally closed, it becomes open now, and this thing goes back. I'm gonna swap the. All right, let me do this. Maybe because I don't want to label many times. Let me do this. I hope it will allow me. Please allow me. Oh, it did allow me. This electrical. Guys, I have no intention to confuse anyone. If I'm moving at the pace where there is even one person confused, please indicate right now. I'm doing this so that I can say 1B2 here. We want to see the reaction for both at the real time. 1B what? 2, this side. Okay? And then mechanical. Observe. Ha. What's happening now? Look at this one. When it gets electricity, it gets closed. Air goes in. It gets open. Air goes in. This one, air, it closes. It was open, it closes. Remember, the state, you need to respect the normal state. That's why they say normally open, normally closed. So next time when they say, what's the state? You start by stating whether it's normally open or normally closed. Even on the electrical side, what's the state of this switch? It's normally closed. This one. When I press it, observe them. This one goes to its normal state, which is open. This one goes back to its normal state, which is closed. I release, you get the reaction. Let me put back, because of I did make some changes. Let me go back to my right. Okay. Let's see. Of the relay and the switch is what? I can understand this. The naming of the relay and the switch, is it the one that makes it to respond? The person is back. Lovely. That one, yeah? Guys, this thing here, this solenoid here, this part, it's actually that part in real life. Ne? We are just assigning it here with a similar term, 1B1, 1B1. In real life essence, I'm just going to demonstrate only that part to answer Mulea. My mouse operating two screens, you will always get confused. Do this. That, are you on? This is on. Perfect. Lovely. Right here. Right. Zoom. I'm going to zoom this. I'm going to zoom this. All right. Ladies and gentlemen, the question the person has asked, I'm going to attempt to answer it. I believe we all can see. Please confirm if you did see the question from that person, or otherwise they must make it to be public. Guys, this It's my solenoid. Let me actually use my phone to get a different angle. Let me use my phone to get a different angle. Okay. Is my phone open? So yeah, it is open. Okay, it's not a problem. I'm gonna do it, attempt one more time. Right. All right. So yeah, that is still a solenoid valve. Guys, I'm saying this is our valve. I need to view myself. I need to see myself. If you're doing things that way, you can't see yourself. Oh, why am I here? What's happening? No. You're at Droid Camp, bro. Yeah. Guys, ladies and gentlemen, showing. Yeah. This part, this is your solenoid, ne? Electrical device. And this is your valve. You understand? So, solenoid valve I want to now lift up my cables. Okay. So from your push button, and then from your push button, you go to your solenoid valve. Okay. So let me maybe unzoom. Okay. Perfect. From your push button, you're going to your solenoid valve. And then, but the computer is unable to connect the two. It only connects them through the coding, the assigning. You understand? So that's your push button. It goes to your solenoid. This is your solenoid. And then the solenoid will be able to power your cylinder. When you press there, there will be an electrical current that goes there. Because in essence, this gets the power from the 24 volts. The 24 volts comes through here and goes out through there. And we have our ground. And we have our ground. That's your ground, your 0 point. So, let me go back to the screen. So, this part is the solenoid. Even this one, they are linked or they communicate through coding because we need to show this, the pneumatic side and the electro side. Then this, even you read here, it will tell you here the different types. They are both the 3-2-way valve, the 5-2-way valve, everything basically. So this is your gate to there. So that's why they need to always be connected through the labeling because we can't physically go there. But with the real wiring, you are able to connect from there to there. That's why they say 1B1, 1B1 there, 1B2, 1B2 there. This is a solenoid. Even this one, it's a solenoid. This here, you see that this is a solenoid. This is a 3-2-way. This is a type 3-2-way valve. It's a type, but the solenoid part is whether are you switching it on through electricity, through pneumatics, through hydraulics. I'm going to zoom something very quickly. The reason why I'm having time to explain this is that going forward, I don't want to explain. I want us to be able to just understand, and I'll keep on asking you a lot of questions. That's why today I'm explaining. So we are having what? We're having valves here. You see, frequently used valves. We have mechanically operated. And then here we have pneumatically operated. Here we have solenoid valves, which are electrical valves. And you have hydraulic valves. If you even go to internet, you would be able to see that. These are the manually operated valves. Then I'm gonna just type the solenoid valve. You see, my solenoid comes different types. And we have hydraulic valve. Do you see that? I'll never lie to you. These are our hydraulic valves. Our software is not able to go to hydraulic valves. So now, the only way to communicate with your solenoid is through this solenoid here. This is equal to that connecting point. That is that connecting point. You cannot run anything. If I would remove the wording here, I would say solenoid. Solenoid. Maybe you're confused by this terminology. Solenoid 1, enter, play. You see, I'm not getting any reaction this side. You see, I'm not getting any reaction this side. So I come again. I come here. I'm gonna tap the very same time. Solenoid 1. And I'm not sure. Oh, the wording can move, guys. For clarity, it can move. Solenoid valve, solenoid 1, solenoid 1. You see it match. You see it match. Activate. You see now I press. I'm not getting a movement. Why I'm not getting movement? All right, let's read the terms. Solenoid. See that their names are not the same. So I'm not referring to the same thing. That's what it means. Noid. And if not mistaken, do you see here? Do you see here? It shows us this is a symbol of almost three-way valve. Do you see that and that? It's almost the same thing. You see that? And then here, let me see here. No, I want to label. Do you see? Valve solenoid, exactly the symbol there. So it shows you where it's supposed to be renamed. Now, you see, I'm getting reaction. I'm now getting reaction. How about we develop a new culture? Let's do away with these funny names and stick to the professional names. How's that? Solenoid 2. How's that? Can we vote? Who agrees? By a show of hands. Who agrees? Or even if you can say yes. So it's annoyed, it's not neoid, it's noid. First and first, you need to make sure the terms are the same and push it aside. So people are agreeing. I'm happy if you are happy, guys. Are we clear? I'm happy when you are happy. So this is how it works. I've sent you from this basically more like we've covered exercise 1. So let's see the memo. Oh, we didn't answer actually the question. It says 2 push buttons. With Tina, we were answering other things. I was covering the ground. So we haven't yet answered the question. I wanted to differentiate the two solenoids. So they said the original state of the solenoid is forward. Ne? This is the one. This is a solenoid that we must choose. Okay. So now let's go back to our studies. We're gonna remove this. So now we're back to school. Back to school. So now we don't have 2 solenoids. We only have 1. So this we can just move it away, and that comes there, that comes there, this goes away, and yeah, remaining like that. So now we need the secondary push button. Right? So I'm just gonna. Oh, another thing, please label like this. Let's do away with text. No more text. We label now. PB1. You see that? PB1. Look how nice it comes out. You see, this is more professional. And I'm gonna copy this, copy paste, and PB what? Label PB2. How's that? Here, we put it power. It has now power. So you connect the anywhere here. We have power, and so I am sure, guys, you still remember this from the ladder logic. I'm sure we still remember this from the ladder logic. This is exactly what we did in ladder. So I want to assign everything straight. I think we don't want to confuse anyone. I don't want to confuse anyone. So I mustn't do funny things. Everything must be straight. Because I don't want to confuse anyone. What do we see? Connect there at the top. Perfect. Perfect. It's perfect. Right. That's just cosmetics. So push button 1, push button 2. This is how we do the OR. I press this, it goes back. I release, it goes to the initial stage, initial location. I do that. Let me press. You see, it's connected through push button number 2. It goes to the solenoid. So both of them, they are connected to their solenoid. Both of them, they are connected to what? To the solenoid. Okay? Memo now, memo type. They used a 5-2-way net, they've converted it. I clearly stated that our software is unable to convert. And this, okay, right? Let's consider this. We used the two-way valve, and it was listed as part of the things that you can use, and they are coming here. Okay, all right. So according to you, something is wrong. Our answer is not the same as theirs. Why? This direct actuation, we are supposed to do indirect actuation. Delete this here, delete that, position this chap here, and I'm going to put the relay. Where do I find my relay? Hold on. And yeah, guys, it's very important for you to know where to find what. Now, close everything. Okay, close this valve side. So electrical controls. I find power supply, measuring instruments, I find relays. Do you see that? Relays, a relay is an electrical component. Okay? I'm gonna connect there. I'm gonna go there. This is a relay. You are used to me connecting it as K1. Again, we said let's use the original terms. Let's use the original terms. Relay 1. Relay 1. You see? Relay 1. Okay? And then the relay 1, how is it gonna switch on there? It's gonna switch on with a switch called a changeover switch. Connect there. So this must match the relay 1. You see, relay 1, relay 1. Okay? At first, we were able to connect, we had our solenoid there, né? And it was able to connect. So let's see now. Look, when the relay is on, we have our relay there on again, and our solenoid will activate. So that is when we do the indirect actuation. And I write it also for that one who's at home, would think on the last day, you just watch this video quickly. Bravo. This is indirect actuation. By default, all questions are indirect actuation. No excuses. Why? Where? Somebody will ask, say about where is the ish. Let me project camera, droid cam. You see, I can't point from here. See now, working alone is a problem. This I/O push buttons, these are your relays. This connection here is direct actuation. When we power through relays is indirect actuation. These are our relays. They are 24-volt relays. If we wanted to power a system that required 500 volt, we were going to put a 500 volt relay or a contactor. In industry, you're going to come across such systems that require high voltage. You will be required to use this connection that we just designed there. You will be required. Or even to troubleshoot, should there be problems. To troubleshoot that it should go back to its normal state. They're just going to call you nicely and say, hey, Matipa, go sort out that thing. Somebody asking me why they're into 2 relay. Where's relay number 2 here? Let's see. I want to go back. Screen. All right. Who is asking? All right. I forgot your name. Matipa. Relay number one. This is how they communicate. This, it's more like when we are moved from solenoid to that solenoid. So there is a physical wiring that communicates there with a relay. That when this relay is on, we're expecting that to be on. So maybe because of I'm displaying a direct actuation, let me now display the indirect actuation, how it will physically look like for Matipa so that he or she could be happy there, understand. I know that's a relevant question, basically. People out there, they're seated with confusion. Let me unconfuse you. I think this one is okay. So 328, all right, it's not a problem. So Okay, unfortunately we have to use it's fine. I'm just gonna do the electrical wiring only, ne guys? So this chap here, yeah, direct actuation went from the push button to here. I must see myself. Not see myself is a problem. Yeah, okay, I can. So it was going directly here. Now we're no longer going to go there. We're going to go to a relay. And a relay comes with its own changeover. Physically, it comes with its own. Oh my God, this is up. Let me go up. Let me go up. Yeah, let me go up. Camera go up. Effect. Zoom. Forcing technology to its maximum capacity. Aha, perfect. Yeah. So a relay, yeah, from there we were supposed to go directly there. Now we are going to a relay. Imagine this relay is a 500 volt. Yeah. Then we're gonna come at 12. Yeah. You. I should hit my. We have 12 there. If you are drawing this, you can just refer to your screen. We have 12 there. That is a closed circuit with 11. So we cannot use that 12. It's a closed circuit. We're going to use 14 because 14 is open. It's going to only actuate when we give it power. And then if you can see, we have also 11. Leave 11 for now. At 14, this is where your 500 volt positive would have been connected at. But unfortunately, we will connect from this 24 volt. I will have some students who just want to make my life difficult. Let me connect from the power supply, J. 14 to the power supply. Okay, power supply is not visible. Imagine that is there. I know. That's my power supply there. I've connected it from the power supply. And then I said, your mind must run wild. This is our 500 volt. Let me come back. Okay? And then we have an output section here that must go where? Who can say 11? From the screen, from 11, where do we go? In your screen it's 1. In the screen is 1. If you were following me, somebody answer from 11. Where do we go? Somebody answer me quickly. From 11, where do we go? Guys, no content. All right, I'll tell you. From 11, we go to the solenoid. I keep on hitting this thing and I'm going to drop my phone. From 11, we go. From 11, which is your 1 on the screen, we go to the solenoid. So, your relay here, yeah, and this part, your changeover, is still the relay. Yeah? On the physical connection, we are working with real wiring. But on the software, we are working with coding. So to assign, we assign. And then we put our negative there. Negative, it must go collect from the power supply in negative. And then from there, everything is connected. Power. And when I press that, the relay switches on. Here, what I'm doing is difficult, but yeah. You see the indicator light there? The relay switches on. And let's see for the solenoid. You see the solenoid switch is on also. That's indirect actuation. Solenoid switch is on also. Okay, place my stand nicely. Oh, where am I facing now? Sorry, guys. These things, everything's just physics. I don't know. Like even the stand, you must make sure it's correctly positioned. So yeah, Matipa, not Matimba, Matipa, my student here. I'm sure you've helped a lot of people who might not admit, but yeah, question was very relevant. One relay. This your, come, computer man. This that relay. That when this relay is on, this relay is on. It comes in the form of a changeover switch, but it is a relay. Okay? Moving along. Next question. Ooh, today's session is going to be long. It's the last one. Let's make it long. I'm going to minimize there and put new array. We've answered it. Come back. Oh, I'm unable to bring this thing. Oh, I can. All right. So in this one, we need to know the function of a double acting cylinder. I'll just, because I'm now flying, it's actuated in both ends. This side for extending, this side for retracting, right? Be familiar with the setup and function of a double solenoid valve. Yeah? A double solenoid valve. Let's call it a double pilot solenoid valve. Yeah? Double pilot. A single acting solenoid valve cannot actuate a double acting cylinder. Only that double solenoid can. So sometimes I can just say use a double solenoid, whereas I'm referring to the 5-2-way valve. You must know. You must know. I like giving all the possibilities. Okay, all right. The question, packages will be diverted from one conveyor to another. Originally, they're going that side. So when you put this to extend, they're now changing the direction. Simple. Moving along. Closing this and zooming. So now, the advancing of the cylinder, you have two push buttons. It is clear. This one, it was a really simple circuit to a point that I didn't want to build it because I have more complex circuits. Ne? Okay, but don't worry. I'll explain it from the screen. I won't build it, please. I won't build it. Can I not build it, please? We still have a lot of questions to cover. I wanted to cover 4. This is the last day, guys. Oh, next semester, I'll be under pressure to complete. But yeah, let's focus on the electrical point of view. Yeah? We have one relay and with its own changeover. So basically one relay even there and one solenoid. We don't have 2 solenoids. So if this is an end function, electricity flow on this is an outer function. Electricity flows there on the top, yeah, and it's able to come there. When it gets here, it realizes, oh, it's open, I can't flow. It goes that side, it realizes that also here it's open, oh, it can't flow. But look at where they join. They join in one point. You see that they are joining at one point. So if you close this side, it is able to flow. If you close that side, that they're able to flow. So this joint here makes the difference. This joint here makes a difference. That's your OR. How would your end look like? How would your end look like? You see, your end would have looked like this, where you would be expected to press both of them at the same time. Unfortunately, I can't press both of them at the same time. So I'll need to change the one of them to be a switch. I would be required to change one of them to be a switch. Let me bring back this O, minus U, come. Switch, where's the switch? This is a switch. See, this is a switch. Connect, connect. Right? So now I'm able to press and hold there. Now you see, both are connected. How clear? My tip. Let's move along. So a diverting gate is advanced when one of the push buttons is activated. How many push buttons are there? There are more than one. First thing first, get to a habit that you highlight also, guys. I give you these things in PDFs. Highlight also. You know there's one push button. If you have to write down, write down. If you have to open the circuit, minimize like I am doing right now, come and put a push button, 1 and 2. Okay, there will be 2 push buttons. You can rename them if you want to. No one is holding you. Rename them P1. The down score, you don't do it. It will happen automatically. P1. Copy paste. Yes, they look the same. I'm gonna change P what? 2. Okay, assuming more than 1. Just start with 2. What do they want? The package is transferred. Okay, and then obviously this, when this advances, it changes direction. So like, yeah, you know, when it de-advance, which is meaning when it retracts, it, you know. So the diverting gate is returned its initial position. When the second push button is activated, we already have the second push button. Do you see that? So, but you can still highlight it. Make your life is highlighted. Okay? And if your memory serves you right, they said a double pilot, double solenoid, something like that. And then I said, rename it double pilot solenoid. You need a double acting cylinder, you must place it there. The cylinder will be controlled indirectly. I stated very clear. Oh, guys, I don't want mistakes. When I in a test don't mention direct, it means you are, somebody answer it. In the event of electrical power failure, the cylinder rod should remain in the current end position. Current end position. So this statement, somebody might not understand this statement that says current end position. It doesn't matter where, as long as if it's on its advanced end position, it must remain there. If it's on the retracted end position, it must remain there. So this is a latching some sort of mechanism. The system can latch. I'll show you how. Select a solenoid valve, correct one, and describe solenoid valve. I've told you how they are different. You can even differentiate them and you understand. Calculate the consumption. I don't care about consumption. The complete the equipment list we label. Complete the equipment list. That's your labeling. Hey, don't write me these things, guys. 1, 2, 3, 4, 5, 6, 7, 8. I'll give you a wrong. You label. Right? We're dealing with electrical. Don't even open the other valves. We're dealing with valves, you see, under valves. We're dealing with solenoid. This is electrical valves. Under frequently used and valves, frequently used valves. They are now mechanical, pneumatic, solenoid. We strictly deal with solenoid. Strictly. Not even by mistake, guys. Don't dare put any other type of a valve. Solenoid. All you use, you find them this side. Simple. We have this. This is a single pilot, 5-2-way. This is a single pilot, 3-2-way. How do we see? This is a double pilot, 5-2-way. How do we see them? The biggest question currently. Okay? Just count here. 1, 2, 3, 4, 5. Oh, so that's where the 5 comes from. The stages of simulation, the stages of actuation are 2. The initial stage here, and the actuated stage. So this one, 1, 2, 3. How many phases of actuation? 2. This one, 5. How many stages of actuation? 2. 5-2-way, 3-2-way, 5-2-way. Let's do this. Yeah. 3-2-way, 5-2-way, 5-2-way. How do we actuate this? We actuate it there. That's right, because you can label once. Can you label this side? You can't. You can label once this side. Can you label the other side? You can't. This one, you can in both sides. That's why it's a double pilot. Double pilot. Obviously, solenoid. Okay? Solenoid. 5-2-way. I can't make it too long. You'll end up confusing. Like this is fun. So this is a double thingy. So this one acts with one push button. That one also requires to be actuated only at one point, on one point. It returns. So this, okay. On this side is how you actuate it. This side is how it returns. It returns using a spring return. This one is how you actuate. That side is how it returns. One is how you actuate. This one is how it returns. But this one returns with activation of a push button or a sensor. Delete these other ones. Double way actuators. This one. And we flow. Today's session is gonna be long. You'll be at home and relax. You'll go through them. Please go through them. If you don't worry. I'll show you gymnastic as a gym. For the test, go through this video, guys. Don't let yourself down. Don't let your parents down. Go through this. Don't even go home without downloading it. Let's start there. If you know that you are going to the Bundus, don't go home without downloading it. Download it tonight. Make sure. I don't want to regret. So this will operate with, it's an indirect. Remember, if it was a direct, we're gonna just, let me just show you a direct that you must never even try. If it was a direct, the circuit was done. Do you hear me? Circuit was done. Done like this. Like that. It's direct, guys. I mean, it looks simple. Obviously. I'm the one who started this. So let me finish it. Solenoid. Spelling. Hey, spelling. Oh, solenoid 1. I'll do something stupid, tell me. Solenoid 1. Come this side, solenoid 1. You see that? Cha. Solenoid 1. Come here, solenoid 2. Come this side, solenoid 2. Now I'm sure you can see the reason why I always do it in a difficult way, or direct and indirect. See, actuate, push button number. Oh, uh, uh, push button 1 key. This one push button 1. The other one you cannot choose. Like that. I press top. Oh, what's wrong? Oh, wait. Here. You see? Extended. Push button 2. Retracted. Direct. It's a direct actuation. Indirect. Come on, move on. Indirect, I'm not in a mood of deleting things. I'm not deleting. I'm moving it away. Move it there, move it there. Again, these guys are connected there. Done. And then, so, oh gosh, you can't be confused. Now we're doing this. So the this is too far. Bring it loose. This, like that. Okay. I was still seeing it. I was still seeing it now. See? And obviously our changeovers there at the top. Left. We're gonna go there. Change over. Hey, change over. These are the changeovers. Change over 1, change over 2. This is what? Who can say what we write here? Quickly, please. Quickly, somebody say something. What do we write here? What do we write here? Something, please, quickly. Seems like our guys are not sleeping. 01. Oh, this guy. Day 1, Baba. We agreed that we use the actual names again. Lay 2. This one. This one there. We have agreed. I will always honor our agreement. I'm teaching you everything so that when I test you to my maximum capacity of testing, you could always be on the same page as I am in that test. Zizobuya, strong. Strong. Okay, I have errors there and there. Error might be generated here. Okay, that's wrong. This is an error. Solenoid 2, solenoid 2. What do you want? Solenoid relay 2. What do you want? Relay 2. Relay 2. And what's wrong? Okay, I didn't read the error. Let me do it again. Oh, do you see what the statement? Hey, over the border. I come here, I click, I go down, I go that side with a right facing arrow. Is my left, man. Bring it home. Hopefully that won't be an issue. Perfect. I press, it goes where? Forward. It remains forward. And I press, you see it connected there, and it is connected there at relay number 2. And I release. Who's confused? You'll redo this alone. And next up, I can see even my fuel now is going down. But yeah. There's the memo. P1, P2, relay. We go there, solenoid connections there. I am not able to go further than this. I think even myself, I can see that fatigue. Let's end here on this one because we had a lot to explain. The next time we come across, guys, I won't have a lot to explain. Please, I would be asking questions. I'll be asking you, what's next? What's next? What's next? Right? We need to appreciate the function of a limit switch, the sensing of positions, and switching element tables for relays. Yeah? So they want you to appreciate the tables for relays. Wooden boards need to be pushed out of the stacking magazine and into the mounting device. All right, as you can see, like that. Let's go straight to the requirements. Okay, we were practicing earlier on with my guy. That's why you see a lot of things being highlighted already. So we're gonna start with what? How many push buttons? We start with the push button. After reaching the front end position, after the cylinder has extended, it will return to its initial position. The cylinder's front end position needs to be sensed. Okay, people, the cylinder's front end position needs to be sensed. Yeah? So we need to design and function of a limit switch. Okay, that's not a problem. Let's just go quickly. here. I'm just gonna amend this for argument's sakes, please. I will just amend this for argument's sakes. So our push button 1 is pressed. Let's say when the extended end position needs to be sensed, né? And that's how it will return. It will never return with a push button, né? It will return with a sensor, and that sensor will work by itself. Okay, so that's how we put the sensor. And oh, unfortunately, I didn't cover that section of the sensor, but it's fine. A sensor is gonna be this, a changeover, and the sensor, something I might not have mentioned, that sensor it's a roller lever. So we're gonna change this to be a roller like that. Sensor is a roller lever, and where is it going to fit in? I press, it remains on. Where is that sensor? How is that sensor going to influence there? That sensor. The sensor becomes positioned like, okay, I can't take anything. Gets positioned with a ruler. Say, I need you to extend that cylinder to go forward. The cylinder length, extend it. Okay. Perfect. Thank you. And I need to go quickly to my camera. I know, not right camera. I don't want that. I want this one. Okay. I'm gonna zoom. They say when the cylinder is fully extended, the sensor must be activated. So that's your sensor there. Yeah? So you put a ruler there to make sure that you understand the okay, I can't see my tape measure, but it's fine. So you are required to understand. You are required to understand the gap there, yeah? And the sensor positioning. So we want to position our sensor. We want to position what? Our sensor. Okay. So now this is how you do it. You place a ruler first. Place a ruler just on top of a cylinder. And you name. What is your sensor? My sensor is the roller. Yeah. And then where is it positioned? Let me zoom this. It says position. You saw where was that sensor being positioned at the maximum. This thing ends at 100. You see that 0 to 100. Where is it positioned? So we're saying it is positioned at 100. 100 and 100. You see that? Where's the positioning of the relay, of the roller? It is possible to be positioned at 0, 0. It is possible to be positioned at what? At 0, 0. Move it to 0, please. The sensor. Okay. Let me for now try this way. Right, 0, 0 there. All right, perfect. Take the camera. Yes. The camera. No. There. Around. Yes. Take it down. Up. Up. Okay. And then play zoom, unzoom it. No, that's just zoom. Unzoom it. Bring it close. Unzoom. More and more. I tell you when to stop. More and more. Sharp. You see a point of 0, 0. Point at the roller lever, please. That roller lever there, that's a roller lever. That's your point of 0, 0. I'm going to show you from the different angle. Okay. So that point 0, 0. That's your point 0, 0. Point 100, you move it forward. Can you pull it if it's loose? So we are sending it to a point of 100, extend the cylinder. So this is your point of 100. Sensor positioning. It's called sensor positioning. 100. If I had a second sensor, I was gonna label there. We're still gonna cover proximity sensors. Don't worry. We will. So now I'm activating my system. Observe. Fully extended. Look at the roller. The roller is active. Look at relay number 2. Relay number 2 is active. I'm letting go now. I'm letting go. It goes back. That. Do you see that? Right. Do you see now? So the practical video for these things, I think we will do them separately until exercise 6. We will do the practical videos separately where we wire for you the exercise 5 where we have 2 push buttons, and exercise 6 where we have a push button and a sensor, which is a roller lever. And then guys, you to remember, for as long as I'm recording, and it's almost 2 hours, the size of the recorded gets bigger, and it might take longer to even download, longer even to watch, which will result for you getting bored while watching it or not able to download it. You understand? You stay in different environments. I stay in a township where even owning a 5G or 4G phone or whatever modem makes no difference. You're still not gonna get internet. So, ladies and gentlemen, I would really like to stop the recording, but I don't mind to engaging with you to just cover up some loop ends where